Epistasis is when two different loci contribute to the same phenotype in some kind of unexpected manner. So multiple different genotypes leading to the same phenotype. To explain this, I'm going to use an example of taking a test at the Delta Testing Center. We've all been there. We need to get a few things before going. First, you need your keys. If you have your keys, you can get in your car. If you can get in your car, you can then drive to the Delta Center. Once you get to the Delta Center, they're going to ask for your ID. Well, crap, guess what, you forgot your ID. Because you forgot your ID, they don't care, they don't know who you are, so they're not going to let you in to take the test. Because of this one thing, you cannot get to the final product. Yes, you made it this far, you got as far as the Delta Center, but that's as far as you got, and you can't continue going forth. All right, so single recessive epistasis is when the homozygous recessive condition at one locus masks or modifies the expression of alleles at the second locus. So with this example, we have big A, big B, little b crossed with big A, big B, little b. And we have to start at colorless precursor. So if we start at a colorless precursor, to get to the purple intermediate, we need a big A followed by a little a or a big A. If we do not have that big A enzyme and we just have two little a's, then we will not get to the purple intermediate. We will stay colorless. If we make it to the purple intermediate, we need to get to the big B followed by a little b or a big B. And if we do not have that big B enzyme, then we have two little b's and we do not make it to the blue product and we say purple. So after crossing these, I got 9 blue, 3 purple, and 4 colorless, followed by a 9:3:4 ratio. This is my work for that one. These are the ones we just crossed, and after crossing them, we get these different alleles and crosses. Because of this, we look at it as 3 ratios. So the 4 ratio is little a, big B followed by something, or little a, big little b. And because of these little a's, we cannot go past the colorless precursor, and we stay as colorless. So that's right here, and then we go to the 3. And it's a big A followed by little a or big A, and then little b, because these little b's we can't get past the purple. So anything with little b's will be purple as long as it has the big A's. All right, and then the 9 is big A followed by something, and then big B followed by something. And those are the big A, little a, followed by anything with big B. So that is 9 of those, which gives you 9:3:4. And then we cross big A, little a with big B, and little a with big B, little b. And after crossing that, we get 2 different colors. We do not get any purple because to get purple, we need little b's. And since we do not have 2 little b's, like little b, then we don't have purple. And then we can get 8 blues because we have a big A something with big B something. And that are these big A, little a with all the big B's. And then for the little a's, it doesn't matter because they're not going to be followed by any little b's. So we get 8 little a, big B followed by something, which is a 1-to-1 ratio of blue and